Hello everyone, welcome to Remote Sensing and GIS for Rural Development. This is week 4, lecture 5. In this week, we have been looking at the data types for GIS, and we have focused on vector data type in this week's lecture. Most of the data that we get from government resources and observation data is in the form of point, line, or polygon. And that data is easily converted into a vector database in GIS. So moving on, we had seen the panel of QGIS, and we also looked at some major tools that we can use for vector analysis. Some examples were given, as in buffer, width, and the use of these tools were also discussed. For those who have to get more introduction of QGIS tools, I will share today's lecture time in looking through the documentation of QGIS, especially for vectors. So these two links I have already given in the previous day's lectures, and I hope you had time to look at these links. These are the same links that we use to read about QGIS, look at the forums, log in and create questions, wait for answers, etc. Now, we will look at specific documentation that we can use for vector analysis in QGIS. Once we click this and through some steps, we will arrive at this web page which talks about working with vector data. So let's check it out. I'm going to click this link. It will open a page. I will have to share the page. Yes. So in this page, what you see is the in this page is where we went and downloaded GIS, the first link. So you click on Discover QGIS. In the Discover, you can get started. Again, to remind, this is the most recent version, 3.28. But we had gone to the stable version. Stable version has been checked long enough on the system, and so it is called stable. 3.28 will one day become a stable version when QGIS goes to 3.4, 3.5, etc. But for now, most users find 3.22 to be more stable, so they use that. You click on the Get Started, and then we have downloaded this, check out documentation, connect with the community. So this is where, as I mentioned, you will go and discuss with community on your spatial data issues, tool issues, etc. And then you'll get support. But we are going to go to the user guide. I'll open it in another tab, and then the menu and tutorials. So in the first thing, the user guide, the left is the contents. What we are very sure about is the data source that we have discussed. how do you do the data source, creating the data and putting it in the browser panel, etc., etc. Creating new vector layers is what I would like to go through here. So here, there has been a tutorial given step by step and with a image of creating a point shapefile with some data they have given. Okay, so you can see that they have used airports in Alaska as a tool, and then they go step, enter the name, enter the field, and then create a new shapefile by using the plus symbol, create a shapefile button. If you don't know this, you can click and it will also open the image to zoom in. And then you go to the projections and coordinate system, you put in what is needed, etc., etc. Okay. As I said, this is not a QGIS or GIS specific course. It will be introducing that. So I'm going to go to the data sources that this software looks at. So there are two data sources: working with raster data, working with vector data. Okay. In the bottom, you can see the 14.3, 14.3.1. They discuss the raster data. Let's click the raster data. What is the difference between the raster and then how it is continuous data, what kind of format it is stored, etc. Whereas the vector data is point, line, and polygon. And they talk about the extensions that I have given. So this tutorial can also be a reading material for you. And they do look at the Esri shape format. So Esri is a proprietary software for mapping. Like QGIS, there is an Esri. It came before QGIS, and hence it has more features, tools, user community, etc. But it's very expensive for a lot of people, so that is why open source has been created. So we promote a lot of open source in IIT Bombay through the FOSSEE program, which is free open source software for science and education and engineering. So it is very, very widely accepted across the globe, this program. And so I would like to also follow that and take QGIS in this NPTEL lecture. So you could see some other formats and how it is being stored, etc. As I said, those who would like to brush up on the basics, the materials are here. You could go ahead and read through it. Okay, so we will go to working with vector data. Okay, so you will have multiple points to discuss. So the vector properties dialog, what it means. Then it will go through each and every point that you would like to discuss in using vector data. Let's say single symbol render. If I click the single symbol render, you could see that how you style your vector data in the database can be done. For example, sometimes the data may come in a particular style and format. It won't look that appealing in a map. So here's where, if you right click on the data and then go to properties, you will get into this layer property data visualization tool and dashboard. In the dashboard, you can see source, symbology, labels, masks, 3D view, diagrams, fields, attributes, etc., etc. The most key, I would say, is source, where you find information about the data, which is called the metadata. Whereas the other important aspect in this properties is the symbology. Please understand that maps you can do to analyze and get data out or analyze the data. That is fine. But at the end of the day, you're also creating visualization tool. So you're going to visualize the results, maps. So the maps have to be well observed by the viewer and stakeholder, for which the styling is very important. In some software, it's called styling. Here it's called symbology. And it gives you about, for example, here, the line is a simple line. It's not dash dash line or a star star line. It's a simple solid line. And the color of the line is given. Opacity is when you place it on the top of a map, is it blocking the data up below it, because maps are in layers. So these kind of very, very important aspects are given. The thickness of the line, what unit is the thickness. If you would like to have a template of design, you have dash black, dash blue, dash green, and effect emboss. These kind of things are there. These are saved styles that you can quickly use without changing color, opacity, width, unit, etc. Again, if you don't know all this, you can always go with the default setting. Some of the data here are default, so you can just click and then say accept, apply, and then it will come up. The other thing I would like you to notice, sometimes the dashboard visualized here on the page will not be the same as your software. This is because the software would have updated. The bullets, the points on the left-hand side would have changed. However, most of it will be there. So don't worry that the system, the way you use it will change. That will not change. Only thing is there will be addition, and some tools will be removed, or some bullets on the left would be removed. So you could see how you could do categorization and then rendering it with names, labels, etc., etc. It's very extensive. It runs through multiple pages. I will not again cover all this, but it'll be good for those who have limited basics to look at this. Okay. So then what you do is you can also come to the general tools, where you have layer panels. What does it mean? Like it gives you the styling doc, new group, filters the legends tree, and then configuring map themes, show all layers, hide all layers, select layers, all these things. Because you will be layering your data, it is good to have only those data that are needed for your map to be visualized. You can have it in your stack on the background, but make sure that you don't have to show all the data upfront. It is not needed. Okay. So this is about your general tools about in QGIS, and more importantly, your user guide gives you how to work with vectors, symbols, and then all the symbols, styling, different symbols, drawing effects, label properties, etc. And then all the left-hand side that you saw, masks, label, join, attributes, everything are given here. So you do have attributes from properties, where you can collect data and then add it in the attributes section. So you can customize your data, you can auto-generate your data, all these kind of things can be done. Again, we will be working mostly with data that is taken from government resources and then applied here as a tool. So we have already seen Bhuvan, NASA data, etc. Most of them are raster data, but we can also look at how to collect data from observation data and then add it as attributes here. Then we also have vector tiles, which tiles are packets of geographic data packed together, because as I said, when you send data or when you share data, sometimes it's better to share as a pack, as a database. That can also be done here, where multiple data are added and then given as a vector tile. I'll go back to the vector data, working with the vector data, working with the attribute table. You have multiple table columns and rows. The columns define the objects whereas rows are attributes, how many entries are there. And then you could do some spatial joining of tables, because in one table there will be location like city name, whereas the other table will not have it, but you know that the ordering is linked to the city, so you can merge the tables. This is very important while working with vector data, because sometimes government and non-government data has the city name and the district name implied, which means they'll have a code, city 1, city 2, like a pin code. The pin code tells you where the location is. For example, you have 400076 for IIT Bombay, and Powai is linked to that pin code. But if you don't want to label it as Powai, you can always label it as a number, if at all the government is collecting like that. So my point is, if you have a data with shapefiles of districts, cities, and towns, you can merge these two together by join tables or a join tables function. These are kind of advanced, but again, sometimes your data requires you to join and merge the data. So that is what we are discussing here. So that is all about this function, working with vector data function. Again, as I said, there are multiple ways you could label your data. There are multiple ways you can access the data, and there are multiple ways you can store the data. So all this have been given here. Please go through it. One tool that we will use more is the field calculator. It is actually used to create new fields, or create new rows and columns based on an existing column. For example, you have length divided by 1,000, and so the function length, dollar length, is how you write it, the syntax. It returns the length of a line string. If you need the length of a border of a polygon, use dollar perimeter instead. So here you could see that dollar length has given the output. The syntax is how you write the code. Here, there's a lot of codes. Sometimes that is where proprietary software will have this as a tool, but here you will have to type it as a code. If you just type it here in the search box and show help, it brings about a lot of lengths, and you know that you want to create the length of the, create a new field where the length of a particular shapefile is stored. So if you can see here, it is create a new field. So in a table, you're creating a new field, a new column, and the column name is called length underscore kilometer, which means the output field is a decimal. It's a number with kilometers. So maybe it was in meters, the length. So length gives you the meter, the length of a line string in meters. So what you would do is you would divide it by 1,000 to get the kilometer. So some simple coding you will have to do, and you have to tell which column, which field you're going to take, and then map it. So you can also do create a new field or update an existing field. If you update, the data will be corrupted or the data would be updated. So as I always said, it's always easier to have a create new field and then preserve the old field, so that you don't, if you do a mistake in these kind of codings and stuff, you don't lose the initial information. So field calculator is where you would go and delete a field, edit a field, convert a field, or even create new fields as given here. The multiple examples given: editing multiples field, how you would edit, use a toggle sign, the pencil sign, if you click and then say edit, and then it will start editing. So all these, as I said, you could go through these tutorials. It has been given in the videos tutorial also, but for those who would like to go through the exercise, you can go through this. It is like a cookbook recipe, we say, where we click, 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 and then each picture, each image that comes is also given in the website. So you can compare and then work through these homeworks. They're given some example data and gone through these exercises for you. Okay. So I will close this, and then the manual is about using QGIS tools, the multiple modules. I would like you to concentrate on the creating vector data. Okay, so here you would say first lesson is to create a new vector data set, feature topology, forms, actions. You can go through the create a new vector data set, and then it will tell you the goal is to create a new vector set. It is not as difficult. It's green in color, so follow along. Which means it just says open, very simple basic steps they will give you. Open QGIS, create a new blank project, navigate to create menu, and then create the field. So each image is given to show you what we're going to do. So this is a create a new shapefile, and the shapefile type is a polygon. So you have 3-point line and polygon. They have taken the polygon. So then you also have, once you create it, you'll have to give a projection and a coordinate system, where the reference coordinate system is given as WGS 84. Again, if you don't know for your location what to give, the forum helps you. You can go and say, for example, what is the CRS for Indian region, and then you'll get it. So then you add field. So once you create the polygon shapefile new database for vector, you will have to have columns where new fields or objects are going to be put. For example, you have a shapefile of states. Then one of the field will be name, right? You want to give the district name or the state name, and then the area, the population, male, female. So all these are fields, objects, and within the field you have data. The rows would become the attributes. So it says, look at this new field. What type of field is it? A string? Is it a number? You'll have to, since it's a name, it's a text data, how much length of the data you want to give, etc. So all these are kind of self-explanatory. You would give within the field, there are two in this polygon, there are two. One is name, and then the other is ID. Name, for example, state Tamil Nadu, and the ID is number 1. 01 would be the ID, and it is 10 in number. So maybe the zip code can also, or the pin code can also be kept here for a unique identifier. Okay, so then you go to raster is another one, but we'll come to this when we discuss the raster. So we will keep this part alone for today. So moving on, they also have training materials in English, Brazilian, French, German, and Czech. There are a lot of tutorials that they say are available. So for example, it says official training materials can be found here. If you click, it opens on the QGIS training modules, classifying vector data, creating vector data. We just went through this tutorial, right? And then there is a workshop written in English, translated in about 15 languages, done by Ujjwal Gandhi, who is, like, as I said, a volunteer who gives a lot of time on these. So if you click this, you can also get into some of the tutorials, all open source, free, based on QGIS. So you have different versions. You have basic operations, you have the intermediate, advanced, and then water specific, etc. And then there is also a tutorial material developed as part of the workshop on ecology and evolutionary biology program at Texas A&M University. So you can click here and then go in. Most of them are not videos, however, it's still okay to go through and do like cookbook recipe. As I said, step 1, they'll ask you to do, and then an image is there. So you will have it. It's written in simple English. It's not difficult, so please go through it. There's a fundamentals of GIS, intermediate of GIS with QGIS and post GIS, and then a lot of coding if you would like to do the advanced part can be done here. So there's introduction, advanced, and customized QGIS with plugins and Python. You could definitely use these. So these are the training materials. And the training materials that we find online are also usable. For example, every entity, private or government agencies do spend a lot of time on these kind of um, tutorials to support students, researchers, and anyone who would like to use QGIS. So coming back, I would like to again stress the fact about QGIS. But before that, I would like you to look at how do you search for vector data. So you have to type shapefile download for India. Just say for searching. So in QGIS, you can see that a lot of download shapefiles, boundaries, Diva GIS, etc. is there. I will explain Diva GIS here. So how you have to search for if you want is just Diva GIS. It opens like this. It's a very useful data archive for point data and some raster data. Once you click Diva GIS or download data by country, you will go through the download program to look at what is this Diva GIS about, how is it free, and then documentation, English and different language, and then how it has become free spatial data. And out of this, what are the data that you can collect? Sometimes it also brings data from multiple resources. For example, here you have Eden project, Landsat data from different resources. The elevation data is also here. So I would like to conclude by just going through this exercise of how do you get country level data. So click Diva GIS. Again, the boundaries may be different. They keep updating, they keep changing these boundaries. So please be very cautious about using it. Use mostly the Indian government websites. Some data, if it is not available, yes, you can use these kind of resources, but be very careful on the northern boundaries and other boundaries of India, because sometimes they do not have accurate information, which is the full coverage. But they'll give you what is the data about. For example, I've clicked India and they tell what are the data that they have and what is the source. So source is this one. So you have administrative boundaries. This is where I'm talking about. The boundaries may not be correct. There is no vouching of these who or the government agency telling that this is the correct data to use. Like this, there will be multiple data online. Please do not use them unless and otherwise it has been verified and the government of India approves it. Here, this has not been approved as the boundaries. So be careful in using it. Maybe if you go to the source and if that is approved, you can use it. But for the southern part, most of these data are accurate, especially the administrative boundaries, inland water, which is the rivers, canals, road network, railroads. Elevation data is same. You don't have boundaries. It's a raster. It's a continuous data. So you can take it. The land use, land cover is there. Population from the census, and then put it in a GIS format. World climate data, world climate or world clim data is pretty good and well used by researchers around the world. It gives you rainfall, wind speed, temperature, humidity. Most of the parameters for climate are given here. And the gazette is also the name of the coordinates, which gives you some administrative data also. Okay, the formats, what type of formats, what is the resolution? All these can be obtained from here, the format and resolution. The resolution is mostly given as spatial resolution. It is not talking about temporal. For example, land use, land cover is for a particular year 2000. It is not every year or every 5 years once. And the units is 30 seconds. You can always convert the unit to metrics by using some formulas. Okay, so once you give OK, it will ask you to download the data as a zip folder. You can download it and apply it in GIS. But again, be careful on understanding the data is been approved by Government of India. So one more link that I would like to share is data.gov.in. So this is a good data set that we can use. Okay, open data platform. Here also you can get a good amount of shape files, and point data. The point data can go into, you can make a shapefile, you can make a vector shapefile as discussed in the tutorials earlier. So for example, you can go here and click. I put Tamil Nadu water. You can click, and then it will tag whatever data it has. So for example, surface water quality from Puducherry, Andhra Pradesh, water bodies, number of water bodies, etc. You can create, it's all in a data set module, like a table. And then you know that table is there, you know it's Tamil Nadu, you can link it with a GIS database. Okay. Sometimes shape files are given as formats. So you can click shape files of rivers. So you can see here the government of India. This is the government of India data. So you can use it. It has been approved and put as a data in the data.gov. You can download as a zip through the URL, how many downloads, etc. So shape files of rivers, airports, and then rainfall points, where exactly you can get rainfall points. If you can click here, more information about the data comes up, and then you can see that published date, updated, what it contains, the data about the data, gridded rainfall points of entire country. So all these are pretty well established, and it is also having a lot of other data. For example, here you have year-wise funds allocated under Jal Jeevan Mission. So this is a very rural development scheme. We have discussed this in the first 2 weeks of the lecture. So basically, this gives you data about how much funds are allocated. Now, for rural development, we need this information because we're going to put it in a map and show that this is how much funds have come, but how is the benefit? So funds versus benefit ratio, you can analyze and work it through. It's shared in Twitter, but the links are coming, take you back here. For example, I'm going to click this. It will come back. Basically, it's a Twitter handle there, but then it goes and comes back to the data.gov.in, where the data is being stored. Okay. Some other, so you can see community data.gov.in, and then you'll have all the data in a visualized Excel sheet or some format. Okay, so you do have a running database. So you can also take these data and then put it in your computer new shapefile. For example, if this is a year fund allocated central share for the entire country, you can see that around 390.31 crores has risen to 3,590 crores in 2020-2023. So in this you can also type it as a attribute value in your database. So a lot of data can be taken. One goal of this is also to give students a link to where you can find data. So there's a visualization tool you can go through, which has been updated on 12th July 2022. And then you can download the data as a table. So you can see here the table is there. As I said, you can convert the table back into shapefile and put it across India. So these are the ways you could find data. I've covered two data sets. One is Diva GIS. A lot of people use it. However, the boundaries could be wrong, and there is no guarantee if the boundaries are working. But data.gov.in has most of the data scrutinized by the government of India. So it is actually a trustable data source. Sometimes there is a less speed in updating, and that is why people use open source data like Diva GIS and other sources. But slowly this is also picking up because spatial data and mapping has been key indicators for nation's development, which has been covered in programs like Gati Shakti and mapping of India water bodies, etc. So with this, I would like to get back to what we have been discussing on the links. We have worked through these tools. As I said, QGIS has been in use from 2002, 20 years at least. Public license, works on all software, open source softwares and operating systems. And multiple agencies are being using it, the US, Swiss, New Zealand, etc. The process is cyclic in terms of using and defining the problem, but please understand that always there is a possibility of from the decision coming back into redefining the problem, creating more data sets, and then updating the data sets. With this, I would like to conclude week 4's lecture. There will be a lot of discussions on agriculture and rural development, which is put up by the Niti Aayog's Vision of New India. And there's a lot of mapping and data that can be used, remote sensing and GIS. I will see you in week 5 lecture. Thank you.